Have you ever stopped and wondered how your AI assistant is suddenly starting to sound well, just like a real person? We're going to break it down. The incredible tech that's making that happen, turning those old robotic voices into truly human-like conversation. Have you ever stopped and wondered how your AI assistant is suddenly starting to sound well, just like a real person? We're going to break it down. The incredible tech that's making that happen, turning those old robotic voices into truly human-like conversation.
It's a really cool story about speed, smarts, and the art of just talking. But look, beating that 800 millisecond clock is only half the battle. Because getting rid of that awkward pause isn't just about raw speed. A fast robot is still, a robot. The real magic is making that voice sound genuinely human. You know that feeling, right? You ask Siri or Alexa something, and then there's that pause, that little bit of dead air where you're just waiting, wondering if it heard you, if it's thinking, or if it just checked out. It totally breaks the illusion of having a normal conversation. And that delay or latency is the number one problem that engineers are trying to solve.
Because in real conversation, timing is literally everything.
Even a split second delay is the difference between a smooth, easy chat and a clunky, frustrating experience. This has kicked off this huge race among developers, a really high stakes competition to crush that delay and finally nail a truly human like conversational AI. The finish line isn't just about making the AI faster, it's about making it feel more natural, more real. So, what's the magic number they're all chasing? It's 800 milliseconds. That's the goal. See, if an AI can hear what you said, figure out a response, and start talking back in under 800 milliseconds, our brains just accept it as a normal human speed interaction. Any longer than that, and we are right back in that awkward silence. To really get how engineers are even hitting this target, we're going to use one simple idea for this whole breakdown. Think of it like a relay race. Every part of the AI's thinking process is a runner. And that baton pass from one to the next has to be absolutely perfect and lightning fast. And just like any race, the very first step is picking the right team. You have to get the structure right. In the tech world, they call it the architecture. But really, it's all about how you organize your runners. It makes all the difference. On one hand, you've got the old school way of doing things, the modular approach or the sandwich. This is where you have separate parts, one for understanding your speech, the speech to text, one for thinking, that's the LLM, and another for talking back, the text to speech. Each one has to completely finish its job before handing off to the next. And all those little delays add up. But on the other hand, you have the new unified approach. This is one single souped up model that does everything at once. It's way faster and even picks up on things like the tone of your voice.
And this is where our relay race analogy really clicks. That old modular system, that's like a clumsy handoff. Each runner just stands there, waiting for the baton to be firmly in their hand before they even start moving. But the unified system, that's like a professional Olympic team. The next runner is already at your full sprint when the baton arrives, making the whole thing feel totally seamless.
Okay, so you've picked your all star team, that sleek unified architecture. Now what? Well, now it's time for the training montage. This is where we look at all the clever tricks and techniques they use to shave off every last precious millisecond. Here are the four big moves that give the AI its winning edge. We're talking about processing things on the fly, using some amazing shortcuts, shrinking the model to make it faster, and making sure it's always ready to go. Let's break them down. First up, streaming. This is a total game changer. Instead of waiting for you to finish your entire sentence, the AI starts writing it down while you are still talking. Then, with parallel processing, it starts creating the audio for the beginning of its answer, while the main brain is still figuring out the end of the sentence. It's basically the ultimate multitasker. Next is a really clever hack called semantic caching. The best way to think about this is like the AI has a perfect memory. If you ask it a question that's kind of similar to something it's heard before, it doesn't have to think it all through again from scratch. It just grabs the pre made audio answer from its memory, its cache, and plays it for you instantly. This one shortcut can skip the slowest parts of the whole process and save a ton of time. The other speed hacks are just as smart. Quantization basically shrinks the AI model down, making it smaller and faster. Kind of like a runner shedding extra weight before a race, and keeping a warm pool of instances just means the AI is always warmed up and ready to run. So you never get those super long 10 or even 30-second delays when you first start it up. But look, beating that 800 millisecond clock is only half the battle, because getting rid of that awkward pause isn't just about raw speed. A fast robot is still, you know, a robot. The real magic is making that voice sound genuinely human. This is where something called neural text to speech comes in. It's not just about saying the words right, it's about getting the prosody, the music of how we speak. We're talking about the natural rhythm, the rise and fall of your voice, the stress on certain words. The best systems can even toss in realistic breaths, little hesitations, and even chuckles to make it feel totally real. There's a catch though. To make a more realistic, high quality voice, you need more processing power. Engineers call this higher RVQ iterations. Think of it like a quality dial. You can crank it up to make the voice sound richer and more detailed, but that takes more time to generate. So developers are constantly trying to find that perfect sweet spot between a voice that sounds incredible and a response that feels instant. And beyond just the sound of the voice, there's the back and forth of a good chat. A huge part of that is knowing when not to talk. A truly intelligent AI has to handle interruptions perfectly. If it's talking and you start to speak, it needs to stop on a dime and listen, just like a person would. And the tech that does that is pretty fascinating. Voice activity detection, or VAD, is kind of like a smart bouncer for the microphone. It filters out all the background noise, so it only pays attention when you're really talking. And then endpointing is this art of figuring out the exact moment you finished your thought so it doesn't cut you off or leave another one of those weird pauses. Okay, so we have a fast AI. It sounds real, it's polite, it's beaten the awkward pause. But for a conversation to feel truly human, it has to have substance, right? It's not enough to be fast. You also have to be right. This brings us to one last super important technique called retrieval augmented generation, or RAG. This is the thing that stops the AI from just making stuff up. Instead of only using the data it was trained on, RAG lets the AI go and pull information in real time from a source you trust, like your company's internal documents or the latest news headlines. And this is exactly why RAG is such a big deal. It's the safety net. It prevents the AI from hallucinating, which is the cool tech term for just inventing facts. It makes sure the answers you get are not only fast and sound good, but are also factually correct and actually relevant to what you're asking. It's what builds trust.
So there you have it. From a clunky, laggy response to a smooth, intelligent conversation, all in under 800 milliseconds. We have seen how architecture, optimization, and real artistry all have to come together. And it leaves us with one last pretty wild question to think about. As this technology gets better and better, what happens when we can no longer tell the difference?